Today's presentation is about the basic concepts of compiler, phases of compiler. So first, before entering into the phases of compiler, we are going to see what is compiler, what are all the types of compiler available, and what is interpreter. What is the main function of compiler is it is going to convert the high level language, that is our source program, into the machine level language. Machine level languages are machine understandable format, and high level language is the program written by the end user, that is the end user mostly will use the programming languages like C, C++, or Java. And there are mainly two types of compiler available. One is cross compiler and another one is bootstrap compiler. Cross compiler, what it will do is like compiler, it is also going to generate the exe machine code exe file, and that machine code uh, that machine code for a particular platform. In that platform, the compiler won't be available. That is cross compiler. And next one is bootstrap compiler. The bootstrap compiler, on the same platform, the compiler is also available. That is the difference between cross compiler and the bootstrap compiler. Interpreter, what interpreter will do is compiler will take the whole source code and together it is going to convert into the machine level language, and an interpreter, it is going to do the execution for each and every line of code, and for each and every line it is going to convert into the machine code. If there is any error, first it is going to throw the error to the end user, the end user have to correct the error, then only the compiler is going to convert a particular line of code into the machine level language code of the exe file. That is the main task of interpreter. And the next one is computer application. So computer application is implementation of high level programming, optimization for computer architecture, design of new computer architecture, program translation, software productivity tools. Implementation of high level programming is, so here the high level programming is the program written on C, C++, Java, and any other programming languages. Optimization for computer architecture. Optimization for computer architecture is the main advantage of computer architecture is the memory hierarchy. It is going to follow the memory hierarchy, and it is also going to follow the parallelism, like pipelining concept and all will be used by the computer architecture. The design of new computer architecture. So design of new computer architecture is either our architecture will use the RISC architecture or it may be using the CISC architecture. Program translation. In program translation, here our translator, either it may convert into the form of binary code, that is in a binary translation, or sometime it may process our database query. So that is a database query interpreter. And the last application is software productivity tools. The software productivity tools, it is going to use either our type checking or syntax error checking, or it may use memory management tools. The next topic is phases of compiler. The compiler, it is going to convert the high level language into this machine code, that is an assembly code. So before converting the high level language into the assembly code, what are all the phases are available? So mainly there are 6 phases of compiler are available. The first one is lexical analyzer, then semantic analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and the target code generation. Lexical analyzer, the another name for lexical analyzer is scanner. It is going to take the source code as an input and it is going to convert into token. Syntax analyzer is going to take the input in the form of token and it is going to convert into the parse tree. Semantic analyzer is going to take the input as parse tree and it is going to convert into the abstract syntax tree. Intermediate code generation is going to take the input as abstract syntax tree and it is going to generate the intermediate code. And code optimizer is going to trying to reduce the line of code, and target code, it is going to generate our assembly code. So all the 6 phases of compiler will be handled by either by the symbol table or by the error handling. The first phase of compiler is lexical analyzer. So lexical analyzer, another name for lexical analyzer is scanner. So what it is going to do is it is going to read the whole source code, that is our high level programming language. It is going to scan the whole code from left to right direction. By reading the code from the left to right direction, it is going to do the grouping of character. So grouping of character, we are going to call it as a lexeme. So each and every lexeme or the lexical analyzer is going to record, and after recording the lexeme, it is going to classify each and every lexeme into the token. So under lexical analyzer, there are 5 kinds of tokens are available. The 5 kinds of tokens are identifier, token, symbols, operators, and the constants. So lexeme may all kinds of lexeme will fall into any one of the tokens. And in lexical analyzer, it is also going to check the lexical error also. Next, second analyzer, and the output for lexical analyzer is going to be the tokens. And next phase of compiler is syntax analyzer. So the syntax analyzer, that another name for syntax analyzer is parser. So here it is going to take the token as an input, and it is going to construct the parse tree as the output. So in syntax analyzer, it is also going to check whether there is any syntax error is available in the particular code or not. If there is any syntax error is available, it is going to inform the syntax error to the end user or to the developer. And in lexical analyzer, it is going to take the regular expression as an input, and in syntax analyzer, it is going to take the context-free grammar. It can accept the context-free grammar. And a third one is semantic analyzer. Semantic analyzer is going to take the input as a parse tree generated by the syntax analyzer, and this parse tree is going to convert into the abstract syntax tree. So abstract syntax tree is nothing but it is going to convert all the integer into the real values, all integer values into the real values. And in semantic analyzer, it is also going to check the compatibility of data type, declaration, initialization of tables, flow checking, and type checking. These are all the thing will be done in the semantic analyzer. So here the whole parse tree can be converted into the abstract parse tree or to the annotated parse tree. And the next phases of compiler is intermediate code generator. That annotated parse tree is going to be the input for the intermediate code generator. With the help of an annotated parse tree, it is going to write the intermediate code. So the intermediate code, mostly it is going to follow the 3 address code. And the next one is code optimizer. So the code optimizer is by taking the output of the intermediate code generator, it is trying to optimize the code that if there is any possibility to reduce the number of lines of code, it is going to reduce it. So that will be done by the code optimizer. So after code optimization, that is a target code generator. In target code generator, after code optimization, it is going to convert that code into the machine language code, that is in the assembly code, by using that instruction like move, add, mul, etc. So after this, the two more tasks are available under the phases of compiler. That one is symbol table management, and another one is error detection and reporting. So these two will be handled by all the phases of compiler. Simple table management, what it is going to do, what it is going to manage is, it is going to have all kinds of identifier, and for each and every identifier, it is going to assign the attributes also. This data structure for the symbol table is recording the identifier, and for each and every identifier, it is going to what kind of attribute it is. That will be managed by the symbol table management. And in error detection and in error reporting, so here error detection and error reporting will be done on the first 3 phases of the compiler, that is lexical analyzer. In lexical phase, it is going to check whether there is any lexical error is there or not. And in syntax analyzer, any syntax error is there or not. And in semantic analyzer, it is going to check whether any type checking error is there or not. So that will be done under the error detection and reporting. So it is going to report what kind that error like lexical error, syntax error, and the semantic error to the end user. So in the next video, we will be seeing an example for the phases of compiler. Thank you.